Yeah. 1, 2, 1, 2. Hi, Mom. So, dear audience, ladies and gentlemen, and innocent victims, who of you noticed the news of the huge denial of service attack against Estonia a few years ago? Or against South Korea last year? Many did. Who of you have ever been involved making denial of service attacks? Just to keep your hands down. Well, I have. We are Rocket Tooling, a software company creating testing tools for IP network equipment and services. We do for IP traffic, which is basically, you guys know, it is internet traffic for services like voice over IP, video, ticket services, Facebook, stock exchange, internet security, you name it. We do for IP traffic what a pressure washer does to water. You know, the problem with testing IP network equipment and services, already in a laboratory I mean, is the lack of IP load and load shaping. And to fix that, we can use any pre-recorded IP session and multiply it up to millions of different sessions or users, even to the level of denial of service attacks. And in addition, we can shape that IP traffic to look like it comes from the live network where you plan to deploy your system, to wash away even the toughest bugs. I bet that most of you guys and gals have never heard of Rocket Tooling, but we have customers in several continents, as far as in India and China. And what we are asking, next time when you plan to acquire, buy some new load generating tools or IP deviation tools, come to check us out too. We have won several competitive biddings, and our public customers like Nokia, former NSN, Ericsson, Exfo, they don't buy for fun, I can assure you that. So, I am Risto Kauppi, CEO of Rocket Tooling, and now let me introduce Director and Technical Guru Hannu Saarenpää. Break a leg. Okay.
Okay, Hannu Saarenpää from Rocket Tooling. I'm responsible of sales and product management. And let's take a look first from where we are coming. We are Rocket Tooling, Oulu-based company. We have really strong experience in telecom, especially in mobile network world, and this is also quite well visible in our product offering. We are mainly selling products to the customers as a product investment, and then customers are using them by own, and we are supporting them. Parallel of that, we have also second business model where we are basically selling services and testing results together with our existing partners, and that way customers are not always mandatory to buy testing tools, and we are basically selling testing results to the customers. That's the outline of my presentation. First, I'm going to talk shortly about a Rocket IP load generator called Ruge, and then after that also a Rocket deviation emulator called Rude. At the end of this slides, I'll explain shortly our demonstration, which we are showing in the reception during the breaks. we are basically demonstrating both of our main products. Besides of that, we have also third product line, which is left out in this presentation, but that is basically for capturing area. This is maybe not main focus of today topics. Our tools and testing solution always needs Ethernet IP connectivity. This is the main point. We don't have any radio frequency connectivity. It is always mandatory to have Ethernet IP connectivity either with the optical or copper interface. We are clearly positioning ourselves to software house testing tool equipments where our competence is clearly software. We are not developing any hardware. We are just using existing available network process unit platforms, which is basically not anyhow customized to us. Our competence is clearly in the ability of developing effective multi-core processors, and this is quite a challenging task to harness all co-processors effective way, and our solutions are really competitive in performance area, and we are able to get a good solution in that area. At the moment, we are having 1 gigabit and 10 gigabit connectivity, and next on way is coming multiple 10 gigabit interfaces in parallel, which are synchronized between each others. We have started also investigation towards 40 and 100 gigabit connectivity. Network elements and testing services is maybe best match to our testing solutions. We are having testing solution for IP load generation, which is following a certain specification. Besides of that, we could easily go outside of those specifications, including those denial of service type of attacks. We are not anyhow limited to certain specification or certain, let's say, operating system provided stacks. This is implemented by our own specialists, and that's the reason why we could go easily beyond these limits. Also, network emulation, realistic testing environment is extremely important. We feel that there is a lot of network services, a lot of network element testing done clearly in too optimal environment. That is causing, at the end in live network, a lot of troubles. If people could and specialists could do this in a more realistic environment, then it would clearly to be seen as a more and better stable environment at the end. Okay, let's take a look at this RUDE product, deviation emulator product. Now we are acting as a man in the middle. There is possibility to connect either 1 gigabit or 10 gigabit interfaces. First task is to trigger which part of data we are going to modify or to do this IP environment or the deviation. We can trigger this data either by, let's say, net mask or IP addresses. We can trigger this data within port numbering or certain services, and then we could hit this deviation in certain part of data, and then the rest is going transparently through, and then that way it is much easier to compare this testing results to optimal services, and then this challenging services, which is mirroring kind of a realistic environment from live networks. Everything is happening in real time. Product itself is causing something like a 10-20 microsecond delay, not more. And there is also possibility to bypass this data completely transparently through, and we are not touching anyhow. Then it is just 10-20 microsecond delay. There is some people are talking about IP environment, some deviation, some emulation, modification. I'm dividing this realistic environment testing to 3 different categories. First is IP packet deviation, which is more related to timing. There is delay, jitters, drop, bandwidth limitation, reorder, things like that. Or jitter without reorder, special case. Then there is also second area where we are touching data content itself. So we are doing data modification. We could affect the checksum calculation. We could do data fragmentation, especially in tunneling case. This is really normal case in live network that packets are getting fragmented, and it is always more challenging to end network element point of view. IP addresses we can change in real time. Port numbering. We could do a lot of things also towards security testing, and we could simulate the environment that some hackers, for example, try to get data through without charging, operator charging. That's also one testing case. Then there is a third category is provocative testing, illegal frames, some bursty data, threshold finding from a key performance indicator, or electrical or software-based line breaks. All of these things could be done in timing scale. So we could use this timing profile. We could define a period of bad state and good state. And then it is looping again all the time from bad to good, and then it is easy to check this recovery of problems. Okay, that was Rugged Deviation Emulator product really shortly from the real usage point of view. Let's take a look at this Rugged IP Load Generator. First, we select. Now we are talking about product which is acting as a traffic source, and we are sending data, and we have to first select how many ports and which direction we are going to send, optical, electrical environment. We have some solution for rich communication service type of data generation. It's normal SIP RTP data transmission with the VoIP clients. Data can be generated from some reference based data or really own pattern or some scripting interface data. There is a different approach available. This product can simulate millions of parallel streams, either with coming inside a specification or within illegal frames within denial of service type of aspects included in parallel. there is some special cases that we have to do real voice over IP session in order to know those parameters which are used in these segments. And then when we know those parameters, it is much easier to attack within those parameters as a besides of denial of service attack. For example, RTP port numbering in SIP call. Accuracy is one big benefit of our technology which we are using. Network processor unit is extremely accurate. We are clearly talking about microsecond level. We are using our own protocol stack, not anyhow operating system provided stacks, and that is also basis of our denial of service data generation. Performance is basically up to line rate. One good example would be, let's say, IPv4 whole IP address range. We could loop in a few minutes completely through. It is really capable and good environment. Yep.
How about the IPv6 space?
IPv6 is, well, it takes a little bit longer time, but, but it is same way supported. IPv6 is, can be looped as well, but my living age is not enough to do that complete range. Okay, then as a normal testing tool, automation interface, normal way, supported, command line interface. It can be automated to bigger testing controlling system where multiple testing tools are controlled from a single interface. It is not always mandatory to use graphical user interface. Well, if we think this all together, it is a good solution for cyber attack simulation. This is meaning that millions of parallel attackers can be combined in one platform up to full line rate. It is big botnet simulation. We could do a lot of various things in this area: UDP flooding, TCP SYN flooding, IP spoofing, just some examples. And it's more than clear that those types of data generation must be all the time updated and modified. And here we have this graphical user interface to do that, that kind of modification really quickly. And that way we can always trying to be in front page, yeah. Okay. Today, in our demonstration, we are having this smaller entry platforms, this other one. That is, let's say, with a less performance solution, not so many NPU co-processors, included less memory and less port capacity. But this below hardware is a really high-end solution, which is currently supporting. We are having in this platform 2 times 10 gigabit interface and 8 times gigabit interface. And this demonstration during the breaks, we have built this way. We have done and taken this reference session, this time just basic video, audio-video stream. We have downloaded this to Ruke product. And this stream we are multiplying with the predefined logic. This time we are just multiplying really basic way, multiplying these port numbers. And then this data is transmitted to the other product, Ruke product. And we have multiplied this to 4 parallel audio-video sessions. And then this Rude product is receiving all 4 parallel streams as a completely independent session. And then we are defining those triggering points for each streams, and we are doing this packet deviation for each streams. And once this deviation is done, then we are forwarding data towards laptop, where is a really basic VLC player, freeware VLC player, and in this VLC players we could see this end results, how this data is deviated. Okay, I think that was my presentation, and maybe next if there is questions.
Any questions?
If not, we can anyway talk in offline during the demonstration.
Yeah, Rocket Tooling will be demonstrating the setup on all or during all coffee breaks, one of which is about to start right now.